Hello students. So in homework number one, I gave you few numerical problems to solve in R. So some of the problems ask you that if the solution is unique or infinitely many solution or no solution. So let's talk about one by one when we solve system of linear equations when the solution is unique, when infinitely many solutions, and when there is no solution. So I will solve one example one by one considering the two variables. So before we start, it is always a good practice to clean up your console by clicking Ctrl and L, clean your plot, and if you have something in your environment, just clean it. So it is always good you should have a cleaner version so that there is no memory in this R. Okay, so let's start. For this particular example, I am going to use a package Mathlib. So let's try to activate it first. Library. Everyone know that we just need to write mat library in MATLAB, and you will see that it is activated. So in this case, they say that suppose we have a system of linear equations such that x plus 2 is equals to 2 and x minus y is equals to 0. So the first thing is there a solution? Second thing is, if so, then is it unique or infinitely many solutions? And the third one is, if it is unique, then solve the system of linear equation using elementary row reduction or the Gauss elimination method. So let's quickly create a matrix A, matrix C is equals to 1, 1, comma, 1, comma, minus 1. And number of rows are 2, number of columns are 2, and by rows it's true. So I created a matrix A. Now I am going to create matrix B. Matrix. My matrix B is C2, 0. Number of row is equals to 2. Number of column should be equals to 1. And per row it should be equals to 2. So let's create matrix B as well. So we created two matrices. So the part one is there is a solution. Let's check if the determinant of A is not equals to 0. It means there is a solution and that solution is unique. So let's try to find the determinant of A using the cofactors. Once I run this one, you will see that the determinant is -2. It means there is a solution and that solution will be a unique solution. There are other ways as well to find that if your solution is unique or not. But once you see that the determinant of A is not equals to 0, then there will be a unique solution. Let's check. Now, using the solve command from the MATLAB, A followed by B, I checked it and I solved it. So now you can see that my x1 is equals to 1, x2 is equals to 1 as well. So it means my solution is unique. There is only one value of x1 and only one value of x2. If ever, if I try to plot it, you will see these two lines, because this system of linear equation, every equation represent one line. So if ever I try to plot equation A, B, then you will see that on the right hand side, you can see that these two lines, they intersect each other at a particular point, and that point is unique. So this value is 1 and 1. So that is a unique solution. All right. Now, our next thing is that if the determinant of A is equals to 0, then there are two possibilities. The solution is infinitely a lot of solutions, and the other is there is no solution. So let's take an example quickly. I copied and pasted in here a problem with the no solution. So suppose we have a system of linear equations such that x plus y is equals to 2, x plus y is equals to 3. All right. So they say that is there a solution? If so, then it's unique or infinitely many solutions. And if it is unique, then solve the system of linear equation using the elementary or Gauss elimination method. So in the previous one, we solved it, this one, but also you can solve it by just clicking, just writing Gauss elimination and write A comma B. So you will see that you will get a solution again. Answer is 1 and 1. Also, if you want to see the operation, just activate this command and make it true and run it. You will see that all the row operations, this was your initial matrix, and then there were like row operations, and at the end of this matrix, like you will see that is 1 and 1. This is your answer. Okay, so let's move to one example where we have a no solution. All right, so again, I am going to create a matrix. A is equals to, okay, I'm just going to copy from here, like A and B, so my time will be saved. So 1, 1, 1, and 1. So, and the other one is 2 and 3. All right. Now I have created another updated matrix A and updated matrix B. The second step is like for this question, is there a solution? Let's say we will say DT is equals to A and then cofactors. If I were to run this one, okay, so I use capital C, it should be small c. Okay, so it is giving me an error, so I should use this small c, and let's run it. So my solution doesn't exist. It means there will be like either a infinitely many solutions or there is no solution. So let let us categorize it. Either I can say that there is no solution in right now, because in that case either my solution will be infinitely many solution or there will be no solution. So let's check again. I am going to solve it using A comma B. Let's check it. what is my answer? It is saying x plus x1 plus x2 is equals to 2 and 0 is equals to 1, which is not true. It is not possible that 0 is equals to 1. So it means there is no solution. If ever you want to visualize it, let's plot it. Plot equation A and B. If you plot it, you will see two lines. These two lines are parallel lines. The red one, it represents x plus x1 plus x2 is equals to 2 is the black one, and the other one is the red one. So you will see that they will not intersect each other at any point. They are parallel lines. So there is no solution in that case. Also, to see, you will just run this command solve, and once you see that 0 is equals to 1, so you will say no, there is no solution. Finally, let's take an example where we have infinitely many solutions. We have a system of linear equation x plus y is equals to 2 to x plus 2y is equals to 4, and we want to check the similar things. Again, in the previous part, if you want to solve it and check cause elimination method and a comma b and activate this command, and you will see that there will be a warning, but still you will see that 0 is equals to 1, which is not possible. Like earlier, I will get the same thing, x1 plus x2 is equals to 2. All right, here's a similar thing. Okay, anyways, let's move forward. So the other thing is that let's check an example with infinitely many solutions. So I wrote rank should be less than the number of variable. This is one of the condition as well, but I'm not gonna cover it in this lecture, but just focus on your infinitely many solution. Again, let me just copy the two matrices from here and update it like 1, 1, 2, 2. This is 1, 1, and this is 2 and 2. And this one is 2 and 4. So now my matrices are updated. I run it. I will find the determinant of A using cofactors, and I got determinant of A is equals to 0. Now let's check if ever I try to solve it. I would say the A and B. Let's see what I get. 0 is equals to 0. In this case, when this condition appear, 0 is equals to 0, it means there are infinitely many solutions. So let's visualize it by plotting these two equations, A and B. Once we plot it, you will see that these two lines overlap each other. It means there are infinitely many solutions. Solution mean the point where they intersect with each other. But in this particular case, red and the black lines, they intersect like they are parallel, but also they are intersecting each other at every point. All right. So these are like three different examples. One, infinitely many solution, then followed by no solution, and unique solution. Again, in the last part, if ever you want to get the row and row operations, just write Gauss elimination and write A, B, and this is equals to true. So you will get 0, 0, 0. It's a same thing. Like earlier we get 0 is equals to 0. Okay, so that's it for the three examples, and I hope that you guys will understand when the solution is unique, when it is no solution, and when it is infinitely many solutions.